All right, class. Today we'll start from the middle of chapter 6. And you can think of today is the class for June 27. So let's have a quick overview what we have learned so far, starting from chapter 5. So if you can remember, starting from chapter 5, what we did. So let's say we have to know the timeline first, right? So basically, let's say year 0, year 1, year 2, year 3. And let's say we have a cash flow end of year 3, $1,000. So we know that how to calculate the present value of this cash flow, right? Now, if rather than cash flow at year 3, if you have a cash flow at year 0, we also learn how to calculate the future value of this cash flow, right? And also, if you know two different cash flow at two different types, we also know how to calculate the appropriate rate. This is what we learned from chapter 5. Now, starting on chapter 6, what else we learned? We learned if we have more than one cash flows. Let's say we have cash flow $500 end of year 1, $300 end of year 2, $600 end of year 3. If we have 3 different cash flows, how to calculate the present value or future value of these 3 different cash flows at 2 different time periods, right? Now, one key thing here, multiple cash flows, different amount. So you cannot say that here all are same amount of cash flows, right? Multiple cash flows, different amount. So you know how to calculate present value or future value when you have multiple cash flow of different amount. Now, this is so far what we learned. Now we are moving one step ahead. Today in this class, we learn what if we have multiple cash flows, but same amount. What if we have multiple cash flows, same amount at equal time interval? Be careful. Same amount of cash flows at equal time interval. How can we calculate present value or future values? If you look carefully, same amount of cash flows, equal time interval. That means end of year 1, year 2, year 3. All cash flows are occurring 1 year after, right? Now, you can argue, why not we calculate the present value of these 3 different cash flows independently and then sum up? Or why not we calculate the future value of these 3 different cash flows independently and then sum up? Yes, definitely you can do that, but it will cost you a lot of time, way more time. Because in finance, there's an easy technique to solve that. Because in finance, when we say we have finite series of cash flows. So by finite series, I refer to the cash flow will end. Cash flow will not continue forever. So in finance, when you say finite series of cash flow with equal amount, there is a very unique name for this series of cash flows. In finance, we call them annuity. In finance, we call them annuity, finite series of cash flow that have equal amount. You can look here, finite series, that means cash flow gonna occur for only 3 periods, finite series that gonna end. Equal amount because each are 200, 200, 200. Make sense? This is known as annuity in finance. So in financial calculator, so far we assume that our payment is 0, right? In financial calculator, they actually refer annuity means payment PMT. So from now on, we're not gonna say payment is 0. Now on, we could input some values for payment, right? So this is called annuity. Now, annuity are 2 types. One is known as ordinary, and the other is known as due. So when we say ordinary annuity, it means all the cash flows will happen or will occur end of the period. So let's say if we say our cash flow will start from year 1 and it's an ordinary annuity, that means Our first cash flow will occur end of year 1, second cash flow will occur end of year 2, third cash flow will occur end of year 3. So when cash flows occur end of the period, we call it ordinary annuity. Now, when you say our first cash flow will occur starting from year 1, but it's an annuity due. So due means cash flow will occur beginning of the period. So beginning of year 1 is basically year 0. Beginning of year 2 is basically year 1. Beginning of year 3 is basically year 3. Now, if you look carefully, the number of cash flows because of due versus ordinary, the number of cash flows because of due versus ordinary did not change. What changed is the timing. So when you say ordinary annuity, we mean first cash flow will occur end of that period, that specific period we're talking about, okay? When you say annuity due, first cash flow will occur beginning of that period. It could be year 1, 2, 3, but beginning of that specific period. So this is the difference between due versus ordinary. The number of cash flow is still the same. Make sense? Only difference is timing. And you have to be careful. Beginning of period 1 is basically end of last period, which is 0. Beginning of period 2 is basically end of last period, which is 1. So this is the difference. Make sense? Annuity ordinary versus annuity due. Now, we can argue that this series of cash flow can occur forever, ever. Yes, they can. They can occur forever if you have equal amount of series of cash flow, which is not finite, which can occur forever. This series of cash flow has a unique name too. This is known as perpetuity. Perpetuity. You can say infinite series of equal payments. So infinite series of equal amount of cash flow that occur at equal intervals. This is called perpetuity. So in this class, we will know how to calculate present value, future value, or interest rate, or number of periods, or amount of payments when you are dealing with annuity ordinary, annuity due, or perpetuity. So I'm trying to give you some heads up about the cash flow. So the thing is that if you really understand financial calculator, and if you really understand the big picture, like the timing of the cash flow, and you can plug in the amount of the cash flow in the timeline, envelope money is easy. All you need to understand what kind of cash flow it is. What you need to understand when the cash flow will occur and the amount. That's it. If you can plug in like this, financial calculator will solve it for you. Now let's move on and talk about some problems. So this is the definition so far we learned through examples. Now let's talk about some problems. So for perpetuity, present value formula basically is a function of C over R. C over R. C means cash flow, periodic cash flow, periodic rate of return, or periodic interest rate. So basically for perpetuity, you cannot calculate future value because we really don't know the future, right? For perpetuity, infinite, we really don't know when it's going to end. We really don't know the future. So basically for perpetuity, we don't know when is the future. But for annuity, we can do both present value and future value. So basically, for annuity, the present value formula is this. For annuity, future value formula is basically this. Here, C means cash flow. Cash flow means annuity. Annuity means payment. R means rate of return, periodic rate of return interest. R and T. Okay. Now I'm giving you some heads up. In finance, when you say only annuity, that's it. It's assume it's ordinary annuity. Because the standard practice, you will always pay or receive end of the specific period. So when you say annuity, that means ordinary annuity. But if you want to refer, if you want to mention annuity due, we have to specifically mention, we have to specifically explain what is annuity due. Make sense? Ordinary annuity versus annuity due. So in that case, we say annuities, that means this is ordinary, okay? This formula is appropriate for ordinary, not due. We're going to talk about due later. Now let's talk about this problem and let's solve it. So it's trying to tell you, after going over your budget, you have determined you can afford $632 monthly payment. You call your bank and find out the rate should be 1% per month. So 12 months and annually 1% per month. So the thing is that we have to always plug in the periodic interest rate. So as we are doing monthly payment, we need the monthly interest rate for 48 months, which is 4 years. So we need total number of periods. So it's already explained there, right? Explained there. How much can you borrow? How much can you borrow today, right? How much can you borrow today? So that means you need to calculate the present value from here. So present value that you need to calculate, right? All right, give me 1 second. Present value that you need to calculate. Now, M is given 48. Rate, or in financial calculator, it says I over Y is given 1%. And then payment. Now we should not say 0. We have to be careful, 632. Be careful. You will be making this payment negative, okay, for financial calculator. Future value is 0 because you will not receive, you will not pay anything end of the period. No lump sum cash flows. 0. So now future value means on top of the payment, are you making any cash flows at end of the period or not? Okay, that is future value. So you're not doing that. What you're doing, series of equal amount of cash flows. Now let's plug in the calculator. First job clear, 48 is N, 1 is I over Y, payment is 632, negative, future value 0, compute present value. So 23,999.54. So 23,999.54. That's the present value. Makes sense. Suppose you win the publisher clearinghouse 10 million, like something like 10 million units. The money is paid in equal annual installment, this much over 30 years, annual installments. If the appropriate discount rate is 5%, how much does it owe today? So this is kind of intriguing and little complex. So it's trying to say you the lottery worth 10 million, but they will pay this much of annuity for next 30 years. Okay. So basically what they're gonna do is like payment of 333.33, right? And it's basically 30 years. And then I over Y is basically 5%, right? Future value is 0. Although it's telling you, the lottery value is 10 million, but we have to find out what it really owed based on the cash flow it's going to provide it. So if you plug in all this information in the calculator, the present value should pop up something 5. That's it. Just plug in this information, you'll get this value. Make sense? Now move on. Again, we're going to buy a house today too. We're ready to buy a house. Okay, that's good. You have $20,000 for down payment and closing costs. So from the last lectures, you know that down payment is something that's going to reduce your loan value. Okay, let's say you want to take a loan of 100,000, but you have to take some down payment, so that will reduce your loan value. Closing cost is something, it's kind of a fee, transaction fee. Closing costs are estimated to be 4% of the loan value. You have an annual salary of 36,000, and the bank is willing to allow your monthly mortgage payment to be equal to 28% of your monthly payment. So that means 36,000 is your annual salary divided by 12. 3,000 is your monthly salary. 28% of 3,000 that the bank max want to give you as a loan. 28% of 3,000. Okay, so 28% of 3,000 that can be used to pay the loan that the bank want to allow you. Okay, max that. Interest rate 6% per year. Make sure per year. So it's a monthly payment. We have to convert to monthly, which is 0.5%. That year fixed rate loan. How much money will the bank loan you? How much can you offer for the house? Okay. So let's do step by step. Our first step, monthly income. So bank said 28% of 3,840 can be used to pay each month's installments, right? Okay. So basically, what are you going to do? If this is our payment, PMT 840, 0.5 is our, so if payment is 840 and is 360, I over Y is basically 0.5, future value 0. How much loan we can afford? Find the present value. Plug in this information on the function calculator. Find the present value. It should be 140,105. Now this is the loan we can afford, right? This is the loan we can afford. Now here's the deal. 140,105. This is the loan the bank will give us max. Now closing cost 4% of this much 5604. And we have $20,000 for closing cost and down payment. So that means 20,000 minus this value, that's my down payment. So this loan plus the down payment, that's the max total price I can afford from this problem. Makes sense? So here it's step-by-step process. What you need to do, we have to identify for each month how much bank is allowing me from my monthly income that can be used for loan payment, which is 28% at $40. So if I make $840 each month payment, 6% annual interest, 0.5% monthly interest for 360 payment, which is 30-year loan, how much loan I can afford? I can afford 140. 4% of 140 is basically my closing. Deduct that from 20,000, 140 plus that, 40, 50,000 is my total price. That's it. Make sense? Now let's talk about this a little bit, about this problem. You want to receive 5,000 per month starting 1 month after retirement, okay? So basically, let's say if we retire end of December 2023, that means end of January 2024, I want to receive $5,000 each month, When we retire, I don't know, when we retire, that's gonna be our year 0. When we retire, that's gonna be our year 0. After that, gonna be our 1 month, I'll start receiving $5,000 as my payment. This is your monthly rate of return. And you want this to continue for 25 years. So 25 years means 25 times 12, 300 number of payments, okay? How much do you need to have in your account at retirement? So basically, your payment is 5,000 positive because I'm receiving it. Interest rate is given 0.75%. IORY, sorry, it's a typo. Now N should be 25 times 12, which is equivalent to 360. No cash flows I am making on top of payment in the future, 0. So how much do you need to have in your account retirement, which is period 0? So that means we need present value. We need to calculate that. So let's see, let's start over. I make a typo, I believe. So 360 is my N. 0.75 is basically my rate. Payment is 5,000. Future value 0. Compute present value. Did I make any typo? Yes, I did. So 25 times 12 is basically 300. Sorry, I made a typo. So let's work over. That's what I was thinking of. Like, it should be 300. Why I'm typing 360? So again, N is 300. Rate of return is 0.75. Payment is 5,000. I'm receiving that's why positive. Future value 0. Compute present. 595,808. So when I retire, when I retire, if I have $595,000 at my account, which can earn 0.75% per month, then I can expect end of each month, I will receive $5,000 of cash flow. That's it. Now find the payment. It's very easy. You have to figure it out. All this information, okay? If you can figure it out, appropriate rate, appropriate number of periods, future value, present value, you can find the payment. Because plug in all this information, then hit payment. That's it. Okay. So suppose you want to borrow 20,000, okay, for a new car, you can borrow at 8% per year, compounded monthly. So that means appropriate rate is this much. 4-year loan, monthly payment, that means 4 times 12, 48 number of periods. What is your monthly payments? Just plug in the information. $48 is here. 0.66667 is here. Present value 20,000. I'm borrowing it. That means I'm getting the cash positive. Future value 0. Compute payment 488.25. Same thing, right? Now you can say, Professor, this is positive or this is negative. So ideally, I told you in financial calculator, they will make sure one is the outflow, one is the inflow. So I'm getting the loan today. That means each month I'll make the payment. So that's why it's negative. Okay, it's not a negative value. It's negative because of its outflow. Make sense? So similarly, you can do that. So practice on your own. Answer is here. So practice at your own. Answer is here. Find the rate. Now, here is a trick. Similar to other problems, find the rate. You need to identify all these information and then hit I over Y. But couple of things. When we have to find the rate, we have to input at least 2 different cash flows, at least 2. Like let's say we have to input at least present value or payment, or we have to input at least present value or future value, something like that, right? So the thing is that make sure one of the cash flow is negative, one of the cash flow should be outflow, other than financial calculator will give you wrong results, right? Let's give you a hypothetical example. Let's say you want to invest for 1 year, $100, and you will receive 110 end of 1 year. Payment is 0. Now, did you see that? It's giving you some wrong results. Because the real result should be for 1 year, if you invest $100, it should be 10%, right? So make sure one of the cash flow should be negative. Otherwise, you may have error or wrong results. Make sure that. Just first caution. Second caution. If you are working with monthly, semi-annual, or quarterly compounding, which is not annual compounding, if you're working with that, this will give you periodic rate, the monthly rate, semi-annual rate, periodic rate. Okay, this will give you periodic rate. So now in finance, it is always recommended report your result in annual rate. Don't report your result in periodic rate. So what I'm trying to tell you, let's walk through this. Suppose you borrow 10,000 from your parents to buy a car. You agree to pay $207 per month for 60 months. What is the monthly interest rate? Okay, it's specifically asking you what is the monthly interest rate. Now, if I input those information, present value is 10,000, payment is 207.58, future value 0, number of payments 60. Oops, I did make a mistake then. So let's clear everything. So 60 is number of payments, present value 10,000, which is my positive. Payment is 207.58, should be negative. Future value 0, compute rate 0.7499. So 0.7499 is basically your monthly interest rate. Make sense? That's your monthly interest rate. If it did not ask specifically what is your monthly interest rate, don't report this value. No. If it's asking monthly interest rate, then you can report 0.7499%. But if it just asks interest rate, what is the interest rate for this project? Always in terms of annual, 0.7499 times 12. So that should be times 8.99. Make sense? The thing is that if nothing mentioned, nothing specifically asked, what is the periodic interest rate, always report in annual rate. That's it. Now let's briefly go over these problems. I think these are pretty easy. Now I'm giving you the answer. I should say, do it by yourself. If you struggle, then feel free to let me know. So for question 1, it's asking you how much would you need to deposit today. That means you need to calculate present value. So that should be the answer. Right? Now question 1B. So you can say this is question 1A. Now question 1B. What monthly rate would you need to earn if you only have 200,000 to deposit? So you need to change some information. So basically, that should be the information. So for here, you can see 60 is N, 0.75 is I over Y, 5,000 is payment. Now then compute present value. For 1B, you can think negative 200,000 is payment, present value, 60 is N, this is your payment, then compute I over I. Make sense? Now let's do 2A. So basically, Q2A. This is Q2A, just plug in the information, and this is basically Q2B. So I'm just giving you the answer, okay? You do it by yourself. If you struggle, feel free, shoot me an email, okay? So pause the video, do it by yourself, and then match with the results. If you find something different, let me know. Future value of annuities. Very easy, very easy. So now you should have the information for payment, N I over Y, present value should be 0, calculate future value. That's it. Because what you are doing, we are making some series of payments. At the inflow or outflow, you are not doing any payment today on top of these cash flows. Now, do that. Okay. So for what we did, ordinary annuity, and I told you if nothing mentioned, assume ordinary annuity. Okay. What if we need to do annuity due? So basically, you can think about this is the problem of annuity due. It's trying to tell you are saving for a new house 10,000 per year that earn 8%. The first payment is made today. How much will you have at the end of 3 years? So that means you're making payments today, end of 1 year, end of 2 year. If I break it down, this can grow at 8% for 3 years. This can grow at 8% for 2 years. This can grow at 8% 1 year. Then sum them up. This is the, I should say, more clerical or mechanical way of solving it. Now, if you want to do financial calculator, your first job to change the mode. So what you're gonna do, hit second, hit payment, second. Did you see that BGN? BGN means beginning. You can also see here BGN. Now change again. So end. When there is end, financial calculator assume this is the idle mode. Nothing mentioned here. But when there is beginning, they will say there, okay? Now, nothing changed. Only change is the mode on the financial calculator. Still you have 3 cash flows. Still you have 8% rate. Still you have 10,000 payment. Still you have present value 0, compute. Future value, did you see that? You still got the same results. Now you can think about professor. We have annuity due, doesn't matter. Same number of cash flows, everything is same. Only difference is timing. If you change the mode in the financial calculator to begin, financial calculator automatically adjusts for the timing. You don't need to bother about the timing. What I'm trying to show you on this graph, how mechanically or manually it works, but financial calculator adjusts automatically. Make sense? Let me know if you have any questions. So here, what you do, we actually try to convert all the cash flows here in this future value and then convert here. You can do mechanically. Okay? Now, when you're done with annuity due, let's talk a little bit about perpetuity. Definition of perpetuity: series of cash flows, equal amount, equal intervals, but infinite series. It will never end. We cannot calculate the future value. We can only calculate the present value, which is C over R, okay? Now it's trying to tell you, look at this example. Preferred stock, right now, $100 per share, that means present value right now, today. Similar preferred stock already has $40 per share trading at and offers a dividend of $1 every quarter. What dividend will we have to offer if the preferred stock is going to sell? So let me explain. There are 2 preferred stock right now in the market. One is V that want to come to the market, and the other one is similar. So here similar means they have similar risk profile, similar structures, okay? So the similar stock is giving you $1 of dividend every quarter and now trading at 40 per share. So let's calculate the required return on the similar issue. So for the similar issue, this is per quarter rate of return, okay? Per quarter rate of return. Now, if Viva is V is a similar stock, similar preferred stock, so we should have this much of required return. So that means if present value is 100, this is the required return. If you solve it, V needs to pay $2.50 per quarter as a dividend. That's it. Similar thing, Just practice by your own. I'm giving you the answer. These are not tough thing. So this is telling you we are considering preferred stock that pays a quarterly dividend $1.50. Okay, good. 3% per quarter is the required rate of return. What is the price today or present value today? Very easy. Use the formula, plug in the information. That's it. Now, so far, what we talked about? We talked about annuity, we talked about perpetuity, right? So basically, when you say annuity and perpetuity, you are talking about equal amount of cash flows. That means constant amount of cash flows for a period of time, right? But annuity and perpetuity can grow. Let's say we're talking about an annuity that will start end of year one with $200 and then grow each year by 5%. So that means this times 1.05 to 10, 5%. So now it's not a constant cash flow, right? Now, if I tell you, calculate the present value, future value of these cash flows, there is no shortcut trick in financial calculator mostly, okay? You can do each individually and then sum them up, or you should use this formula. Your cash flow is 200, recorded rate of return maybe 10% or whatever, growth rate is 5%, growth rate, record rate of return key should be 3 because I'm talking 3 years, plug in the information, get the answer. Here's an example. Similarly, perpetuity could grow again. You have to use this formula. And here's an example. So what we learned today, we are mostly dealing with annuity and perpetuity, okay? But annuity and perpetuity can grow. So if we talk about only constant annuity and perpetuity, financial calculator is our best friend. If you're talking about growing annuity, growing perpetuity, we need to use the formula. So that's so far for this class. In the next class, we'll wrap it up this chapter.